I can determine the slope of a line given the graph or the equation. Here's what you need to know. Slope is another way to describe the steepness of a line. Slope can be negative, positive, 0, or undefined, and here are examples of that. Positive slope goes up from left to right. Negative goes down from left to right. Zero slope means it doesn't shift up or shift down, it's just a straight horizontal line. And then undefined slope is a vertical line. Slope is the ratio of the change in y to the change in x. We can also write that in this way. Slope is the change in y divided by the change in x, or the difference, the subtraction between your y's, divided by the difference or the subtraction between your x's. We also call this rise, how much you change up and down, divided by the run, or how much you change from left to right. This entire thing is also on your formula sheet for the Georgia Milestones EOC. To find the slope from an equation, you just need to go find 2 points that are on the line and then plug them into the slope formula above. So point number 1, we're going to use x and y to show the coordinates, and I'm using a subscript or a number in the floor of 1 to show that this belongs to point number 1. I'm going to do the same thing to show point number 2. This is just a weird notation that we use to name which point we're talking about. To find the slope from a graph, you're going to find the coordinates of 2 points on the line by looking at the picture, and then plug those coordinates into the slope formula that you see above. If the points are super easy to see, like whole numbers that are real easy to find on your plot or on your graph, you can just count your spaces of rising and running instead of plugging them into the slope formula. So here's an example, a visual of what we're talking about. If we have the 2 points in blue, -2, -1, and 4, 3, and we want to find the slope between those 2 points, the slope of this blue line, we can either take the coordinates -2, -1, and 4, 3, plug them into the slope formula. So I'm going to subtract my y values. I'm going to subtract 3 and -1. Remember that when you subtract a negative, it becomes plus a positive. That's why we're getting 4 in the numerator and 6 in the denominator. Simplified, my slope is 2/3. That means that I rise 2 spaces between my points, and I'm running 3 spaces between my points. Let's check that out. My y change, or my rise, is 2 spaces. So here's, this one counts weird, okay? It counts by 2s or halves. 1, 2. And then my x change is going to be 3. So here's 1, 2, 3. And again, this graph isn't labeled, but you can see that our scale is just off a little bit. But our y change, our rise, is 2, and our x change, our left and right, the run, is 3. Let's do an example. Find the slope of the line y equals 5x minus 2. If you're familiar with slope-intercept form, you already know the slope just by looking at the equation, but let's go ahead and calculate it out the long way just to make sure we truly understand the definition of slope. Here are the steps. We're going to find any 2 points on the line by plugging in any numbers that we want to for x and getting the y values as our answer. I'm choosing to plug in x equals 1, and I get 3 as my answer. That means the point 1, 3 is on my line. I'm also choosing to plug in x equals 2. I'm getting 8 as my answer. That means the point 2, 8 is on my line. Now I've got point number 1, point number 2. I can plug those values into my slope formula to calculate my rise over run. I'm going to take my y values, which are 8 and 3, and subtract them. I'm going to take my x values, which are 2 and 1, and subtract them, and simplify to get a slope of 5. If I plot them on this graph over here, you can also visualize your slope. So I've got my orange point and my blue point, and we're going to visualize now this rise over run. So my rise should be 5, and my run should be 1. My run is the one I'm happening to do first. It's this blue line. You can see that that is a distance of 1 unit. And my rise happens to be a distance of 5 units. So I've got 1, 2, 3, 4, 5 between the points. That's my rise. And then my run is 1 unit between the points. Rise over run. I'm getting the same thing no matter which method I use to identify my slope. Go ahead and pause and try this one. Find the slope of the line 3y plus 2x equals 10. This one is not in slope-intercept form. It's a little bit trickier to just visualize your slope. So let's begin by finding 2 points that lie on our line. I'm going to plug in x equals -1 and x equals +2. You can plug in whichever points you like. And now let's put it into our slope formula. I'm getting -2/3 as the slope. We could also graph it and see if we're getting the same thing. My run is 3 units, and my rise is 2 units. But pay attention that the rise right here is negative. I went down 1, 2, depending on how you look at it. Obviously, I could start at the blue point and count up, but you do have an overall negative slope to this line. It goes down from left to right. So you need to make sure that your slope is negative. It doesn't matter if you make the top or the bottom negative, but it is an overall negative slope. Since your whole slope is negative, just make sure that either your numerator or denominator is positive, and then the other one would be negative. Generally, we put the negative sign on the numerator. That's just a kind of like a tradition that we do. We usually just put the negative in the top so that we don't forget it. If you want more on this topic, be sure to check out the Learning Target spreadsheet for additional resources, videos, and practice.